In this video, I'm going to take you through a few things on solids, liquids and gases and try and show you how you can use number lines, which you've come across in maths, to represent the melting and boiling points of different substances. And from that, you can tell then at different temperatures whether a substance is going to be a solid, liquid or gas. Now, solids, liquids and gases we've talked a little bit about in our last lesson. So you should have seen solids. So quite often one of the examples we show of a solid is something like that, a brick. You're very familiar with it. And you know that solids have got a fixed size and a fixed shape. Okay, so they basically, if you lift a brick, no matter where you put it, it keeps the size, and without taking a hammer and smashing it, you can't change the shape of it either. Liquids, on the other hand, now they're slightly different because if you have liquid, so here for example some milk being poured from a bottle, now in the bottle it was one shape, when you pour it into a glass it's the same shape. But if you keep all of the liquid transferred, no matter which container you put it into, you'll change the shape of it, but you won't change the actual volume of it. You'll keep the same amount of it each time. So we normally say that liquids have a fixed size, as long as you don't lose any of the liquid, it's got a fixed size, but they don't have a fixed shape. They take up the shape of the container that they're put into. And you're familiar with that from your look around liquids at home and everything last week. And then finally gases we're very familiar with in terms of things like balloons and so on. And you know that within a balloon, the gas has got a certain size and a certain shape. But as soon as you open that balloon, you pop it or something like that, the gas just goes everywhere. And the size of the gas, eventually it'll fill the air. And you're familiar with things like perfume being sprayed from bottles. You've got a certain amount of the gas in the bottle. As soon as you release it, it spreads and it goes through the room, it goes through the house and everything like that. So what we say with gases is that they don't have a fixed size. It'll actually expand to take up the maximum space that they can. The gases just get as big as they possibly can. And they don't have a fixed shape. Whatever container they're in, that's the shape that they take up. So those are the properties of solids, liquids and gases. So solids, liquids and gases are three distinct, what we call phases. They're three different substances. Now we're familiar with the changes of them. So you're very familiar with ice melting. So I've got a couple of little videos, very short videos, just to show you some of those things. So I'll show you first of all ice melting. This is a time lapse. Obviously it's happening much quicker than it normally does. And here you can see the solid blocks of ice. And as the ice warms up and turns into liquid, you'll see the shape changes. So we saw there. And you'll see that it changes from being a fixed shape into one that can take up whatever container it's in. Water boiling, again, I've got a very short clip of this. And again, something that you're very familiar with, and there's things that we'll do in the lab at different stages, which is just basically where you heat it, and you can see there inside the liquid, you've got big bubbles of steam and so on formed. So I'll put that back again. This is a very short clip we've got. So as we heat it, you can see there the big bubbles of steam, and that's basically the water turning from a liquid into a gas. So the liquid's here, and then the bubbles obviously are of the gas. And finally, condensing. Now we're familiar with this on things like windows. So this is a little demonstration of a thing you could set up yourselves very easily. Just get a glass and put some ice cold water into it. So some ice cubes and a little bit of water, and then just leave it to sit for a bit. And again, this is a time lapse. This has been speeded up. And eventually what happens is water from the air hits the cold surface. You can see it go misty, and we're familiar with calling that condensation. And then eventually what will start to happen is big drops of water start to form and start to run down the outside of the glass. And that's water as a gas turning back into liquid. That's condensation taking place. So those are things that we're very familiar with in everyday life. Now what we're going to get you to do is a little exercise to look at what we call the boiling point and the melting point of substances. Now, boiling point, this is normally an experiment we do in the lab, and if we get back in before the end of June, we'll get you doing this experiment. And this is where you work out the boiling point of substance. So we tend to use water as a good demonstration. So what is the boiling point? Well, the boiling point is the temperature at which a liquid becomes a gas. We saw there in the beaker being heated, we saw the liquid turning into a gas, and what we do is we measure the temperature of it. So to do it, we set up this apparatus. So this is a boiling tube. You'll recognize from our sort of look in chemistry before that this is the shape of a boiling tube. And you'll see off to the side of it is a little glass tube, and that's what's called a sidearm. So we would probably call this a sidearm boiling tube. We put a little stopper in the top, and in the top of that is a thermometer. The label will come up, there's the label. So we've got our thermometer. And then we take off any gas, just so the gas doesn't sort of go over you and everything. We put it along another glass tube called delivery tube, and then to stop any steam or anything burning you, we put onto this, and this is what we sometimes call a receiving test tube, or a receiver. And we basically heat it, so the arrow indicates that we heat it, and then what we can do is we can get the liquid being boiled. And as the liquid boils and it turns from a liquid into a gas, it'll pass up here into the delivery tube and then eventually in here. And then the temperature is read using the thermometer. And using this, we can measure the boiling point. And we find that different substances have different boiling points. So we illustrate that in class usually with a couple of different liquids showing the boiling point of those. Now, that is the temperature at which the liquid becomes a gas. We can also measure in a slightly different way the temperature at which solids melt. So again, the definition of melting point is the temperature at which a solid becomes a liquid. And those substances, if you take substances like ice melts at 0 degrees centigrade and then boils at 100 degrees centigrade. So you can take ice, you can turn it into liquid water by heating it up to 0, and then you could take that liquid water and turn it into a gas by heating it even further up to 100. So what state would it be in at different temperatures? So for example, if you had 4 degrees centigrade, would it be a solid, liquid or a gas? How do we think about that? Well, if you think about it, 4 is above 0, so it's above its melting point, but it's below 100, it's below its boiling point. So it will have melted, it'll have turned from a solid into a liquid, but it won't have boiled, it won't have gone from a liquid to gas. So therefore it would be a liquid. Now, that sort of thing is sometimes easy to do in your head, but sometimes it's quite hard. So what we usually do is a little exercise where we do it in terms of a number line. Now, as we said, if you've got your page, you can just draw a line. The only bit really that you need from this next slide is that line there. So you'll see me indicating along there. And then mark nice and evenly along the line the numbers. And then we can work out, use this number line, you'll see in a wee moment how we do this. We can use this number line to work out what state sulfur, this for the first example is going to be sulfur, would be at these 3 temperatures. So how would we do it? Well, the first thing we're going to do is we're going to color code it. So you choose a color. So in mine, you'll see at the top of the screen there, I'm going to indicate any solid areas in blue. I'm going to indicate any liquid areas in yellow, and I'm going to indicate any gas areas in green. So that's my color code. So you do that, get 3 different colors, or if you haven't got colors, do different shades. You can shade things differently, and so on. So you'll see where we put this in the number lines in a moment. Now, then look at the information. So it says mark the states of sulfur in the following number line. So the melting point is 117 and the boiling point is 275. So the first thing we do is we go down to our number line and we mark where we're going to put our melting and boiling points. So let's do the melting point. So it's 117. Now, what I'll do is I'll move the little cursor along. You see that red cursor? I'll move it along. And you think, where am I going to stop? Where am I going to mark that melting point? So as we go along, we're looking for 117 degrees centigrade. And hopefully you've thought somewhere around there. Okay, so what we do is we mark that. There's the melting point. So that is the melting point. Now, what it means is anything below that melting point, if you have sulfur anywhere down here below 117 degrees centigrade, it must be a solid. So we're going to put that on in a second. Right? We're going to shade that area blue to show us a solid. Now, above this, it will have melted, so it must be a liquid. But we've got to be careful because at 275, it's going to boil. So let's mark the boiling point. So again, look at the red cursor, and we're going to go to the line and put 275. So you think where 275 is going to be, and hopefully you've thought about there. And then we'll mark there. There's the boiling point. Now, what that means is that if we go along this number line, down here, do you remember it was below 117, so it won't have melted, so it'll be a solid. When you get above that temperature, this will have melted, so it'll be a liquid. So right along this part here where we're showing with the red cursor, that's the liquid. But then when it gets to 275, it'll boil and it'll turn into a gas. So let's shade those in. So this area is solid, so that's why I put my blue. This area is liquid, that's where I put my yellow. And this area is gas, and that's where I put my green. So pause the video and then you mark your worksheet or your page so that you've got that. And then what we're going to do is we're going to take a look at these, what the state would be. So pause and have your number line coded the way we've shown. Okay, so to work out the state then, if you understand that, then this next wee bit hopefully is fairly easy, because the question is, what state would sulfur be in at 35 degrees centigrade? Well, all that we have to do is go along our number line and find where 35 is. So there's 0, there's 50, so 35 is going to be somewhere around here. And you can see that's in the blue zone of this. So that would mean it's a solid. Now, I haven't got it animated there, but you could write in 35 degrees centigrade would be a solid. What about the state at 278? Well, again, go along our number line. And you can see that if we go along the number line, there's going to be 250. This was 275, do you remember? So 278 must be just over here. So it's in the green zone. So that means it must be a gas. So 278 degrees centigrade, it would be a gas. And then finally, 129. So if we go along here, there's 100. That, you remember, was 117, so we're a little bit above it. So 129 must be somewhere around there. And again, you can see that's in the yellow zone, so it must be a liquid. So what looked a difficult question at the start suddenly becomes easy if we use our number line. Now, there's another example underneath it. I'll work through this in the video, but if you feel confident enough, pause the video and then try it for yourself and do the same thing. So mark the melting point, mark the boiling point, put your color codes, show where the solid areas are, show where the liquid areas are, show where the gas areas are, and then see if you can work out what state it would be in at those. And in a moment I'll go over that. Okay, so going through it fairly quickly. So this time the melting point is minus 40. So if we go along our number line, there's minus 100. That must be about minus 75. There's minus 50. And minus 40 must be about here. So yeah, there's the melting point. And then this will boil. Bromine boils at 35 degrees centigrade. So let's go along. And there's 0, 10, 20, 30. So 35 must be somewhere around here. So there's the boiling point. I'm just about to put it in so it doesn't cover that. So marker color code. Solid would be below the melting point. So that area there from minus 40 below is solid. Between the two arrows is going to be liquids. There's our yellow to represent our liquids. And then above that is our gas. So anything above that's gas. So then the question is, what state would bromine be in at 25? So let's go along our number line and find 25. Well, that is 0. That was 35, so 25 must be down about here. So it would be a liquid. So again, you could write in there that it's a liquid. Minus 69, now it's a minus in front of it, so be careful with that. So going back here, 0, there's minus 50, that must be minus 60, so minus 79 must be somewhere around here. And that obviously means it would be a solid, so you'd write in solid there. And then 129, well, let's go along the number line, 50, 100, 110, 120, 130 must be around here somewhere. So that's in the green area. So it would be a gas. So that's how we can use number lines to do that. Now, there's two more examples. And again, if you are able to print them off, that's great. If you're not, just simply get a page, write wax, do this line, just draw a straight line. You can copy the numbers off this and then see if you can work that out. And then once you've got your number line done, put down is it solid, liquid or gas at those three temperatures. And then once you've done that, do the same thing for alcohol. Now, we've made it a little bit more for you with alcohol. You can see that both on the sheet or on the slide here, you can see that I've got the number line, but I haven't put numbers onto it. So you put numbers onto it. Hopefully you can do that fairly simply from before. And then do your key code in the same way. Mark where the solids, the liquids and the gases are going to be, and then work out what the state would be at 25, 120 and minus 103 degrees centigrade. And then could you take a picture of certainly examples 3 and 4 for me and send that through on the Google Classroom, and I'll take a look at that. All the best. Bye.